So let's move into the Jurassic and start off with the geology before we get into the biology. So by the time we get to the Jurassic, here you can see the paleogeographic map. So you can see that Africa and South America have clearly pulled off and separated away from Laurentia, and we're now developing, right, the Atlantic out there. The Appalachians at this point are only going to continue to get smaller. They are no longer building. They're just simply eroding away. However, we're going to talk more about what's happening out here in the west. We're going to see some mountain building, lots of mountain building out there. And we're gonna concentrate actually a little bit down here where we live, right, in the Gulf of Mexico region, where I live at least, because we're going to see that this is going to form a nice big evaporating basin. As South America pulls away from Laurentia, we've got this big beautiful basin that fills in with water, but it's going to evaporate, right, quite a bit and leave behind lots of salt. So we're going to talk about that importance there. But mostly here you can see that reinvasion of the seaway, right? Remember in the Triassic, the seaway was really just restricted out to the west, but by the time we get to the Jurassic, right, we've got that seaway has reinvaded there. So remember, as I mentioned, right, Africa has really now pulled off North America. They are no longer attached. And because of that, right, because that rift now has opened up down to the base of the lithosphere, we've got all of these lava flows that are present all over that rift valley that we see out in the east. Remember in the Triassic, we saw the sedimentary rocks get deposited. Now that that rift is deeper, right, we're going to see all these lava flows. And this is pretty neat. If you were ever to go up, say, in New York and walk along the Hudson River, you'd see these really, really cool structures. And this is from basalt, right? So this is basalt that's cooling and crystallizing slowly, and it leaves behind these really big columns. So to me, that's really cool. You can go walk and see this, and this was the true edge of North America, right, during the Jurassic. They said as Africa pulled away. So really, really pretty neat stuff there. As we move down to the Gulf of Mexico region, as I said, the Gulf of Mexico region is just going to be one giant evaporating basin. As the water evaporates, it's going to leave behind a lot of salt. Now that salt over time is going to eventually get buried. And living down here, right, we tend to know that there's a lot of oil and gas that can be found in the Gulf of Mexico, right off the coast of Louisiana. And salt is actually the key to that. So salt, when it's compressed, acts like a liquid, right? So originally, right, we're going to have, let's see, here's the bottom, we're going to have layers of salt, right, that are going to get deposited, right, as they form from water evaporates away. We're going to deposit more sediment, right, on top of that. And this compression, right, pressing down on this salt, so that salt acts like a liquid, so the salt wants to move upwards. So what happens is the salt tends to form what we call a salt dome. Again, I'm making this very simplistic here, but as it moves up, right, as we push down on it, it's going to move up. And as you can see, it kind of bows these rock layers around it. So what happens is, naturally, in this sand unit that's here, lots of oil is going to collect in that sand. Now, in a nice flat sand unit, it can be pretty tough to extract the oil out of there, right? It's in sand. However, if we could tip that sand unit upwards, all that oil is going to flow to that upper spot. And when this salt dome, right, when this salt moves upwards, you see it's bending those layers, and all of that oil here now can move on upwards, right? It's going to collect in that upward spot. And if you notice here on the surface, this is where we have our oil rigs, right? They're tapped in there right next to that salt dome, right? So salt domes are of great economic importance here because they allow us to easily extract the natural gas and oil out of the rocks, right, that it's bending around it. Salt is also important here because of salt. If you've ever been to Avery Island, where they make Tabasco, there's a huge salt mine there. It's not open to the public, but it's a big salt mine. And that's what they're mining out, right? This huge salt dome that's there. And that salt is used to make the Tabasco. So pretty neat there. All right, so as we noticed, right, we get the big epicontinental seaway that kind of reinvades during the Jurassic. And the sea is going to transgress and regress, right? So we're going to see it kind of pulse in, and it's going to pulse out, and pulse in and pulse out. So, right, as you can see, as this first picture shows you, as that seaway comes in, right, it's coming in, you get lots of dunes that are going to sit there off to the side, which are really behind some pretty amazing structures. As we talked about when we looked at that Triassic-Jurassic sequence, right? If you think back again about Zion National Park, these are those huge dunes from the early Jurassic there, from that Navajo sandstone. Okay, if you ever get a chance to go to Zion, it's quite mind-blowing out there. But the sea that reinvades at this time we call the Sundance Sea. And the Sundance Sea is going to regress, and it's going to leave behind this big plain where you're going to have this big meandering river that's going to move across it. And this meandering river is really important. The deposit that's left behind is called the Morrison Formation. The Morrison Formation is by far one of the most widely exposed formations from this time period, probably of the world, really. There's an immense amount of Morrison Formation that's exposed, and it is just rich in fossils. So what we tend to see is these dinosaurs or any animal gravitates towards water as they're approaching death, and their bodies, right, fall into the river. And as this river is pulling these bodies down river, as the river bends, these bodies are going to get stuck in those bends. So what we tend to see is major amounts of fossils can be found in the bends of these ancient river structures. And when I'm talking about immense, I mean the bone density is almost mind-blowing, how many dinosaurs you can find in one location. So the Morrison Formation is really, really important because it provides a lot of information, right? We really have a good picture of what the Morrison Formation was like. If you want a good picture of what the Morrison was like and what these bone beds look like, I'm going to refer you to another national park. Take a look at Dinosaur National Monument. It's where they left a big wall with the dinosaurs intact in there, so you can see the bone density of all the dinosaurs in this formation. All right, so we're going to continue on building mountains out in the west, right, in the Triassic. We saw the Sonoma orogeny. Now we're going to get another wave of island arcs. So again, right, we've got these little island arcs, right, sitting off the coast, and they're going to come in like a bunch of linebackers, right, and collide with the western part of North America. So, of course, the ocean, as you can see here, is subducting. These volcanoes are going to come in and collide. But what's really interesting is, right, with the Sonoma orogeny, right, we saw deformation out here. With the Nevadan orogeny, that deformation is going to start to shift eastward. We're going to start to see the deformation come in here. So basically what's happening is these island arcs, again, I'm going to make this very simple. This is actually a very complex geophysics problem. But as these island arcs come in, the center of North America is anchored. Okay, really the center is off in Kansas, but the map doesn't go that far. The center of North America is anchored. It's not going anywhere. And we've got these island arcs that are coming in and pushing it, right? They're pushing into the continent. They're colliding with some pretty great force. So what's going to happen is that center isn't moving, and we're going to start to crumple. Right? We're crumpling the zone. And once you crumple something, stress can transmit a lot easier across those faults. So we see this stress being transmitted a little bit further inland. Plus, what we really see is down here that this angle of subduction can change over time. And this is going to become important as we move into the Cretaceous and look at some of those later orogenies. But what we can really see is this angle can change, and it can start to affect, right, further inland, right, where you get steep subduction. It's going to affect over here, but these angles of subductions can change, right, become less steep over time. As it becomes less steep, it's going to affect the more interior of the continent. So what we're going to see as we move through the deformation of the Cordillera is we're going to see the deformation march eastward, right? We're going to see deformation just move more and more inland. But during this time, because of all the subduction, we have 3 very large bodies of magma, very large batholiths that are put in place. We have the Sierra Nevada batholith, which is very large, and we're going to talk about the Sierra Nevadas and how this becomes exposed in the Cenozoic when we get to that chapter. We have the Idaho batholith, which is also very large, and the Coast Range batholith. So these are big magma piles, magma pantries that are put in place as the ocean plate is subducting beneath, right, and just melting. It's providing all of that magma that's just sitting there. So in the west, as we're starting to see, we're starting to get lots of these big mountains. And as you've learned in physical geology, basically mountains are very heavy. So when we have a mountain, right, so here's a mountain, it's going to kind of push down on the crust. Right? It's like putting a weight on something, right? It's pushing it down. So we have what's called the Foreland Basin that develops right there in the trailing edge of our mountains. And those foreland basins are going to be really important because it's going to collect an immense amount of material, right? As material erodes off these mountains, it's going to get collected right there. So in the Foreland Basin during the Jurassic, we have lots of coal that gets deposited. And this is really impressive, right? We have, coal that's under 300,000 square kilometers of the Rocky Mountains. That's a lot of coal that's getting deposited in there. And this is important because this is one of those clean burning coals, which just means it has a lower sulfur content. So this is important because we still use it today. All right, so this is a good place to stop because this is going to conclude our Jurassic geology, and we'll continue on in the next video with Jurassic life.